Have you ever heard of an old saying, never look someone in the eye while eating a banana? Welcome to the Fact Check channel. If you haven't subscribed, please do. Many people think that it's a myth when someone pops a question. Is it true that bananas are radioactive? And that is absolutely true. The simple mention of the word radiation often evokes fear in people. For others, it's fun to think a little exposure to radiation could turn you into the next superhero, just like the Hulk. But what is radiation? Radiation is energy that travels from one point to another, either as waves or particles. We are exposed to radiation from various natural and artificial sources every day. Cosmic radiation from the sun and outer space, radiation from rocks and soil, as well as radioactivity in the air we breathe and in our food and water, are all sources of natural radiation. Bananas are a common example of a natural radiation source. They contain high levels of potassium, and a small amount of this is radioactive. But there's no need to give up your banana smoothie. The amount of radiation is extremely small, and far less than the natural, background radiation we are exposed to every day. Bananas have naturally high levels of potassium, and a small fraction of all potassium is radioactive. Each banana can emit 0.01 millirem, 0.1 microsieverts, of radiation. This is a very small amount of radiation. To put that in context, you would need to eat about 100 bananas to receive the same amount of radiation exposure as you get each day in United States from natural radiation in the environment. Like bananas, Brazil nuts contain potassium, but they also contain a small amount of radium that is taken up from the soil in which they are grown. What are health effects of radiation? Scientists have been studying the effects of radiation for over 100 years, so we know quite a bit about how radiation interacts with living tissue, and its effect on the body. Because we can measure radiation and because we understand its health effects, we can work safely around it. It's all about the dose. As with other types of toxins, the dose makes the poison. We receive low doses of radiation from our natural environment every day. We know that radiation at high doses can cause cancer, could harm fetuses, and can even lead to death. Factors that affect dose. A dose received over a long period of time is less harmful than the same dose received all at once. A dose to a part of the body is less harmful than a dose to the whole body. Children and young adults are more sensitive to the effects of radiation. How radiation affects your body. Radiation can damage the DNA in our cells. High doses of radiation can cause acute radiation syndrome, ARS, or cutaneous radiation injuries, CRI. High doses of radiation could also lead to cancer later in life. Radiation measurement is all about energy. When working with radiation, we are concerned about the amount of energy the material is emitting. The size, weight, and volume of the material do not necessarily matter. A small amount of material may give off a lot of radiation. On the other hand, a large amount of radioactive material may give off a small amount of radiation. We measure the amount of radioactivity by finding out how many radioactive atoms decay every second. These atoms may be giving off alpha particles, beta particles, and/or gamma rays. Radiation dose. Radiation dose is the amount of radiation absorbed by the body. What are 3 factors that affect the amount of radiation exposure? Some people are more sensitive to harmful effects of radiation than others. There are a number of factors that influence an individual's sensitivity to radiation. These factors include age, gender, other exposures, and genetic factors. Age. In general, exposed children are more at risk than adults. Natural radiation in food should not be confused with food irradiation. Food irradiation is a process that uses ionizing radiation to prevent foodborne illness, food poisoning, and food spoilage. Food is passed through a radiation beam like a large flashlight to kill bacteria, molds, and other pests in food. The irradiated food does not come into contact with radioactive materials, and food irradiation does not make food radioactive. Artificial sources of radiation include medical treatments and X-rays, mobile phones and power lines. There is a common misconception that artificial sources of radiation are more dangerous than naturally occurring radiation. However, this just isn't true. There are no physical properties that make artificial radiation different or more damaging than natural radiation. The harmful effects are related to dose, and not where the exposure comes from. Let us first understand the difference between radiation and radioactivity. The words radiation and radioactivity are often used interchangeably. Although the two are related, they are not quite the same thing. Radioactivity refers to an unstable atom undergoing radioactive decay. Energy is released in the form of radiation as the atom tries to reach stability, or become non-radioactive. The radioactivity of a material describes the rate at which it decays, and the processes by which it decays. So radioactivity can be thought of as the process by which elements and materials try to become stable, and radiation as the energy released as a result of this process. How radiation affects your body. Radiation can damage the DNA in our cells. High doses of radiation can cause acute radiation syndrome, ARS, or cutaneous radiation injuries, CRI. High doses of radiation could also lead to cancer later in life. So, is all radiation dangerous? Not really. Radiation is not always dangerous, it depends on the type, the strength, and how long you are exposed to it. What is ionicing and non-ionicing radiation? Depending on the level of energy, radiation can be classified into two types. 1. Ionicing radiation has enough energy to remove an electron from an atom, which can change the chemical composition of a material. Examples of ionicing radiation include X-rays and radon, a radioactive gas found in rocks and soil. 2. Non-ionicing radiation has less energy but can still excite molecules and atoms, which causes them to vibrate faster. Common sources of non-ionicing radiation include mobile phones, power lines, and ultraviolet rays, UV, from the sun. As a general rule, the higher the energy level of the radiation, the more likely it is to cause harm. For example, we know that overexposure to ionicing radiation, say, from naturally occurring radon gas, can damage human tissues and DNA. We also know that non-ionicing radiation, such as the UV rays from the sun, can be harmful if the person is exposed to sufficiently high intensity levels, causing adverse health effects such as burns, cancer, or blindness. Importantly, because these dangers are well known and understood, they can be protected against. International and national expert bodies provide guidelines to ensure the safety and radiation protection of people and the environment. For ionicing radiation, this means keeping doses above the natural background radiation as low as reasonably achievable, for example, only using medical imaging on the part of the body required, keeping the dose low, and retaining copies of images to avoid repeat exams. For non-ionicing radiation, it means keeping exposure below safety limits. For example, telecommunications equipment uses radiofrequency non-ionicing radiation and must operate within these safety limits. Additionally, in the case of UV radiation from the sun, we know to protect against exposure using sunscreen and clothing when levels reach 3 and above on the UV index. It's also important to note that inasmuch as radiation is dangerous to our health and with all the risks involved, scientists have managed to generate it and use it to our advantage. For instance, 1. Medicine. Hospitals use radiation in a wide range of ways. X-ray, CT, and PET machines use X-ray and CT, and gamma radiation, PET, to produce detailed images of the human body, which provide valuable diagnostic information for doctors and their patients. Radionuclides are also used to directly treat illnesses, such as radioactive iodine, which is taken up almost exclusively by the thyroid, to treat cancer or hyperthyroidism. Radioactive tracers and dyes are also used to be able to accurately map a specific area or system, such as in a cardiac stress test, which may use a radioactive isotope like technetium-99 to identify areas of the heart and surrounding arteries with diminished blood flow. 2. Radiography. Essentially high-powered versions of the types of X-ray machines used in medicine. Industrial radiography cameras use X-rays or even gamma sources, such as iridium-192, cobalt-60, or cesium-137, to examine hard-to-reach or hard-to-see places. This is frequently used to examine welds for defects or irregularities, or examining other materials to locate structural anomalies or internal components. Industrial radiography is also very useful for secure, non-invasive scanning at security checkpoints, such as airports, where X-ray baggage scanners are in routine use. Larger versions of the same machines are often used to examine shipping containers all over the world. 2. Food safety. Food irradiation is the process of using radioactive sources to sterilize foodstuffs. The radiation works by killing bacteria and viruses, or eliminating their ability to reproduce by severely damaging their DNA or RNA. Since neutron radiation is not used, the remaining food doesn't become radioactive itself, leaving it safe to eat. This method is also used to sterilize food packaging, medical devices, and manufacturing parts. In conclusion, though bananas are naturally radioactive, the amount of radiation is very small, hence these foods do not pose a radiation risk.